Hi, I'm going to present you today my analysis about IMDB um, score of for nearly 5,000 movies of data set. This is the business and data understanding. So, what makes a movie successful? The right combination of talent or chemistry and timing, or with all some good luck? So how can we actually tell or predict the greatness of a movie even before it's even released? These are some of the puzzle questions that's been there for a long time, but there is no universal way to climb the goodness of the movie. So we are gonna take some data set here and move on to understand how can we actually analyze this predictions. So the objective of this project is there are many factors that even though there are many factors that comprise a movie's success, as it is not always clear how they interact. So this project attempts to determine these factors through the use of machine learning techniques. So if I am hired as a business analyst to predict how well a movie could perform in theaters, so this is the data that I would collect from IMDb, Netflix, Rotten Tomatoes, and Wikipedia, and kind of merge it to get the right features. So, but here we are the provided a data set which I'm gonna which have these features, which contains these 28 features in it. So we are gonna use these particular features to predict the results today. So this is the data ETL process. There are nearly 5,000 rows and 28 features in it. The all fields should mean numerical for correlation. So exploratory data analysis. The first step in ETL is I'm gonna go by each field by field and try to understand the importance of each field. So this is the color is the first one. So as we can see, there is nearly 95% of the movies are just color. So it's just like constant, which is really does not help us to predict the score here. So we can we can actually delete this feature. The next one is language. As we can see, English is the main language of all the movies are released, so this feature is almost nearly constant. And next is the country, and USA is the large production of movies by far, so which is also nearly constant. So here what I have actually done is just group all the rest of the countries into other, so that it's gonna make it the analysis simple. So we create the dummies for each country, and the next one is Zonar. Zonar has actually a lot of options, so this is how we have I have tried to create a different data set for just for zoners, and uh, and 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 try to understand if it's even a really important feature or not. And this is the distribution of IMDb ratings across the genres, which is almost nearly, if you can see the area plot, it's nearly each and every genre is just nearly constant. I mean, um, concentrated in a single deep IMDb score. So it actually means that genre doesn't really impact the IMDb score. Even if you see the mean of the IMDb scores across the genres is almost the same if you just remove the outliers there. Next is just a correlation plot, where we can understand the correlations of each coefficient, each feature, and which is positively correlating with IMDb score, and which are negatively correlating with IMDb score. This is just a IMDb or number of voted users in plot. As we can see, the number of voted users is positively correlated with the IMDb score. The next step is data cleansing, where we can drop duplicates of each movie title, and then drop certain columns where we just realize that those are not the important features to predict IMDb score, so we can drop them, such as color, language, genre, director names, and so here the total Facebook likes and actor 2 Facebook likes, actor 3 Facebook likes, these are actually summed up. These are as they are very highly correlated with total Facebook likes. We've dropped all of them and then just keep actor 1 Facebook likes, just for the convenience of analysis. And data pre-processing is where we can actually see that bin response column, because we made it 2 bins, which is the good and bad. So when the data imputation of missing values, so this is the heat plot of missing values in each feature. We try to, as we can see, gross and budget, we cannot entirely drop these columns. I mean, we cannot entirely drop the null values, because we can actually replace them with the mean values in there, and then drop the rest of the columns, if any, are still null. And then the content rating is actually have several values, which does not make much sense in today's rankings. So this is the Wikipedia page where there's different set of content ratings, where we can replace them with the current content ratings. So these are the few steps that I've taken to replace and certain content ratings to just align with the today's ratings. This is where the final values are just 5 of them. We have all grouped the rest of into just to make them for just 5. And then the aspect ratio, where we can see that mainly 2 of them are 1.85 and 2.35. So we could actually replace, as you can see, the mean value of all the aspect ratios are almost same, which is, we can say this is nearly a constant feature, which does not really impact IMDb score. So next is business intelligence, where we had plotted different histograms and to just understand the relationship between the particular feature and IMDb score. This is the relation between movie Facebook likes and IMDb score. As we can see, the pattern is clearly increasing with the number of likes. The score is increasing too, which is positive correlation, as we can see. And this is an implant, um, or category plot, where the movie Facebook likes is separated by content rating. As we can see, um, with the high Facebook movies with high Facebook rates, or is increasing with are increasing with the score, and the low movies with low Facebook rates are just so varied. So yeah, the correlation analysis, as we can see, the heat map for um, the cleared features. And then the modeling, we tried, it's for our modeling, we'll follow the methodology that is greatly highlighted in this the infograph, which is coming here. See, this is the workflow that we have followed to build regression, classification, and clustering models. The regression is, I've tried recursive feature selection, random forest feature selection, and with the important features that identified, we built linear regression, multiple regression model, in fact. Now, I tried ridge regression with L2, as a prior as a regularizer, and I tried SVM as we, and then come to classification. We have been the IMDB score into two categories, which is 1 to 5 is either 0, or 6 to 10 we can consider it as a 1, which is good in the movie prediction. So I've tried decision tree, KNN, logistic regression, random forest classifier. Select K best is just a feature to select the methodology to select the best features, which I've tried. Recursive feature selection is also such kind. I tried to know the importance of each feature and tried SVM2, the gradient boosting classifier. Plotted RVC curve to know the accuracy of each and every classifier algorithms to know. And this is the clustering part where I dropped all the theory part of I mean the objective fields, and just only had the numerical columns to cluster. So, and then I normalized data to make this computationally simple and easy. And this is a k-means clustering algorithm using with normalized data, and these are the two clusters that's created, and just a plot of clusters, which is almost a overlap, and then the agglomerative clustering using normalized data. And here is a dendrogram. So as I can say, the storytelling would be as I can say, this data set has a limitations in this approach, is that we allowed ourselves only to consider as input features those which are known about a movie pre-release. For example, we could surely have achieved higher success rates if we consider the award that movie would go on to win. So, but this did not seem very insightful data set. Our data set was also heavily skewed to movies post 1980, as many before that did not have an accurate financial data. So anyway, some key findings would be movie Facebook likes pattern seems to be increasing with score. That means movie with high IMDb score tend to have high Facebook likes, and movie with high Facebook likes tend to have higher IMDb score, but the score for the movie with the low Facebook likes vary in a wide variety of range. And also um, the multiple regressions in I have identified that multiple regression model taking which takes the below features is did the best in predicting the score with high low mean square error and high variance of 37%. And gradient in classification models, gradient boosting classifier did best prediction, did the best prediction with 91.86 model accuracy and 0.6 AUC score. And k-means clustering is a good proposed clustering solution for automatic initialization of centroids and increased performance by using normalized data. So this is my conclusion. So as while near perfect predictors someday would be machine learning triumph, it could also lead to an overly algorithm approach to movie planning. Studios might be less willing to take risks, and underlying are often some of the most exciting products of the Hollywood. Hope we get the best movies in coming days. Thank you.